Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video we are going to see about the relay operating principles, electromagnetic attraction relays and electromagnetic induction types of relays. So these are the main two types of relay operating principles. One is your electromagnetic attraction relays and second one is your electromagnetic induction type of relay. So normally this electromagnetic attraction type of relay, in the sense it operates by a wedge of plunger triggered by a solenoid or a armature being attracted to a poles of a electromagnet. So it can be used in your both AC or DC supply. Whereas electromagnetic induction type of relay works on the basis of a electromagnetic which means induction principle. So the torque which developed will cause the movement, which means contact making in the electromagnetic induction type of relays. Generally, the relays are like a switch, which is a fast acting switch actually. So, any fault persisting in your system means it should act in a frequent of time, and that fault uh, area need to be rectified, which means isolated. So, for that reason, we are going with the relaying of your operation of your system. Next, electromagnetic attraction type of relay. So the electromagnetic force extended on a moving element is proportional to the square of flux in the air gap. This is the working principle of your electromagnetic attraction type of relays. In relays, normally we have a circuit breaker, auxiliary switches, then circuit breaker trip coils, then protective relay seal in coil, then protective relay targeted area, then protective relay contacts, then auxiliary seal in relay contacts, and the auxiliary seal in relays coils. So these kind of all the coils and uh, tripping areas and the relay contacts and the protective relay contacts, all of them will combine each other, and then these relaying operations will be carried out. So this is your formula for actuating total actuating force. F is equal to K1 I square minus K2, where F is your net force, K1 is your force conservation constant, I is your RMS magnitude of current in actuating coil, then K2 is your returning force. Normally reset to the pickup time for the DC relay is up to a 60 to 90% of your pickup time. Then for a AC relay up to a 90 to 95% of your pickup time. For example, if your uh, net force is 0 due to the verging of your pickup time, so the operating characteristics will be changed into a K1 into I square equal to K2, which means uh, in summation the I in one side, so we will get uh, root of K2 divided by K1. So these are all the single quantities of your attraction type relays. Then coming up to the main portion, operating principle. So a movable armature is connected with the contacts for open and close of your operation. It is magnetized by a current flowing in a actuating coil, and a reversal of your polarities of your actuating contacts will reverse the magnetic polarities of a end of your armature and cause the contacts to stay open. So here polarizing or a field coil is for magnetizing the polarizing magnets as a X and Y sections are also been shown in your upcoming diagram. So in here the force tending to move the armature will be expressed in a F is equal to K1 into IP and IA minus K2. So F is your net force, K1 is your force conversion constant, IP is your magnitude of current in polarizing coil, and IA is your magnitude of current in your armature coil, K2 is the restraining force. In here, if the force net force is equal to 0 means automatically uh, IP into IA is equal to K2 divided by K1. It will comes like that. So from the overall formula, we can came to know that the If direction either IP or IA is reversed, then the force, which means your direction of force, will also be get reversed. If permanent magnet polarization is used, it will cause a constant magnitude of current to flow, which means IA is equal to IK2 divided by K1 into IP. So this is the diagram of your overall explanation which given before. So as I said, actuating coil and that is placed in your movable armature, and that is fixed with the other end with the contacts for closing and opening. Then that actuating coil is triggered to a actuating quantity source, which is your AC or DC source. Then the polarizing coil, in which the battery connections are been done, and the polarizing magnitude, which is having a axis of x and y. Here the actuating contact is mainly responsible for your production of your polarity, which means determination of your polarities will be take place in that. So in that manner, your operation, close and open operations, will be carried out in the relays. Next, coming up to the induction type. So the induction type relay is a like a split place induction motor with the contacts. So the actuating force developed in a movable element, that may be a disc or a rotating, which means a rotor of non-magnetic current conducting material. So it is the carrying operation by a interaction of a electromagnetic fluxes with the eddy current that are induced in a rotor by these fluxes. So these actuating structures are made up of four kinds of structure. One is your shaded pole structure. Second one is your watt-hour-meter. Third one is your induction cup and double induction loop. And fourth one is your single induction loop. We will see one by one now. First one is your shaded pole structure. So this is your shaded pole structure. In here, we have a current flowing in a single coil on a magnetic structure containing an air gap. So the air gap flux produced by this current is split into a two out of phases. So this is that out of phases two structure is called as a shading ring, or nowadays it is replaced with a shading coil. And this shading ring or shading coil is made up of a copper. um, then the rotor is also made up of a copper or a aluminum disc, pivoted so as to rotate in the air gap between the poles. So the phase angle between the flexes piercing the disc is fixed by the design, and consequently it will does not enter into the other considerations. So these are the overall structure of your shaded pole structure type of actuating. Next is your watt-hour-meter. So in the name itself, you can easily know that it is mainly used for your energy meters, watt-hour-meter. So the structure consists of mainly two separate coils on a two different magnetic circuits. So each will provide a necessary fluxes, which means two necessary fluxes for driving the rotor, which is placed in between your uh, two magnetic materials as a like a disc shape. So this is your watt-hour-meter structure, and next one is your induction type and double induction loop structure. So it is mostly like an induction motor, except that the rotor iron is a stationary, which means the rotor material is a stationary material. Only the rotor conductor portion will move freely. So the induction cup, in the sense the hollow cup which is placed in between the portion, that's why the name came as a induction cup structure. So these structures are more efficiently used for producing the torque than the normal of your shaded pole or the watt-hour meter structures. Next, we will see some example of your double induction loop structure and single induction loop structure. So that between rotor portion will get deferred in your double induction and the single induction loop structure. So the stationary portion is the main changes. So this is your single induction loop structure. So this is also most efficiently used for your torque producing structures, and it is very less effective comparing with the double induction type of actuating structures. So hope you understand, I think so. These are all the basics of your relay operating principles. Have a nice day. See you next video. Keep sharing and gain your knowledge. Thank you everyone. Nandri, vanakkam.